So in chapter 1, we look at functions and relations. So a lot of it is a review of what we've done in grade 10 and 11. Yes, Rachel?
It's different.
You mean it's different?
Like,
That's what
interval
Addison had.
notation first to start.
That's what I It's a little bit different, but
Okay.
it'll be fun, okay? Well, interval notation is just a way of putting your domain and range, okay? So,
It's cool.
yeah, because it's even different than what I have. So the first part with interval notation, poor Rachel's like freaking out right now. Interval notation is a way of doing domain and range. So not last year. Crap.
I did not know. You
Okay.
kind of did.
Last year when you guys looked at, or in grade 10, when we looked at domain and range, because that's what interval notation is talking about. What is domain? I should read the section right, Julia.
So like values of x?
Yeah.
Yes.
So then what is range? Possible values of what? So in grade 10, when we looked at domain and range, we looked at ways that we could express domain and range. And there were a couple of ways that we could do it. We could say it in words. So if I had a linear function, the domain is all the possible values of x. It could be any x value that I can imagine would be on that graph. So we could say it in words, all the possible values of x. We don't like using words. In math, if we can find a symbol, we use a symbol. So there's two different notations that we rely on probably more than anything else. One is set notation, and that's the squiggly bracket notation. So that was the squiggly bracket where we'd say it's the set of x values such that x can belong to what number system?
Real.
The real number system, because that's my rational and my irrational numbers. Okay? Interval notation, think of it as a graph. If I was to graph my x values, what's the smallest x value I could possibly have?
Negative infinity?
And what's the biggest one that I could have? So I could go from negative infinity to positive infinity. The only question is, I have to put brackets on these two ends. And the brackets that I put mean something. So if I use square brackets, it includes that value. If I use curved brackets, it does not. Infinity is not a number. Infinity is a concept. So infinities take the largest number you can think of and add 1. Because infinity keeps going on and on. So I use curved brackets for infinity. That is interval notation. So if we look on that page that I don't have access to, really that's what they're talking about. Interval notation is a concise way of describing the solution. So instead of using set notation, I can use interval notation when my numbers belong to the real number system. I can't use interval notation if I'm only talking about integers. I can't use interval notation if I'm only looking at the whole numbers. Okay? Does that make sense? Okay, so now I can go back to the first page. So in this unit, we will develop, or we will review, our understanding of operations on functions and composition of functions. So if we look first of all at polynomial functions. Polynomial functions is what we started last year and the year before. A linear function is a type of polynomial function. A quadratic function is a type of polynomial function. Polynomial functions is an f of x function, because it's a function I can use the symbol f of x. And all of this symbol in here, all it means, the an just coefficients. And then my x's are my variables. So I could have 7x to the power of 6 plus 5x to the power of 5 plus 4x to the power of 4 plus 2x to the power of 3 minus 1. That's a polynomial function. And we write our polynomial functions so that our exponents decrease, so we write them in descending order, and we put the constant at the end. That's really what all of this is saying. So when I'm looking at a polynomial function, the degree of my polynomial function is the highest exponent that I have. So what would the degree of this equation be? Or this expression?
Oh, that one. Sorry, I was looking at 6.
6. And then my leading coefficient, so the degree would be 6. The leading coefficient, find that highest exponent, which was 6, and it's the coefficient with that. So if this had been a -7, the leading coefficient would be -7. So the leading coefficient is tied to that highest exponent. And then my constant is the term that does not have a variable, which is why it's called constant, because it doesn't change. The value of this term changes depending on what x is. So if I look at the example that I have here, f of x is 7x cubed plus x to the power of 4 minus 8x squared plus 5. If I was to rewrite this in descending order, what would I start off with? X to the power of 4. And then?
7x to the power of 4.
Followed by?
-8x to the power of 2.
And then plus 5. So in descending order, my f of x equation would look like this. So what's the degree of this function? 4, because that's the highest highest exponent. What is the leading coefficient? 1. So if there's no number in front of the variable, the coefficient's going to be 1. And what's my constant term?
5.
What? Yeah. Sorry, I thought it was a -5. We commonly look at 3 types of polynomial functions: linear, quadratic, and cubic. We will, in our polynomial functions chapter, we will examine functions that have a 4th and a 5th and a 6th degree in terms of what the graph could look like, but it's not where you're expected to draw the graph to any sort of precision. There'll be certain things that we'll look at. We'll look at where the zeros are, so the zeros being where it crosses the x-axis, and the general shape. And all, like my x to the power of 4, x to the power of 6, x to the power of 8 graphs all have a very similar shape, and my x cubes, my x to the power of 5, to the power of 7, all have a similar shape. So it's learning the characteristics of the shape. The one thing that I will caution you about is with the calculator. When it comes to functions and graphing, I really stress the characteristics behind the graph so that you could sketch the graph without the calculator. Because in those high-level university courses, which several of you could be looking at next year, one of the things that they could do, or a lot of times do, you don't get to use your graphing calculator. You have to know the characteristics of the graph. Okay? So with that said, let's look at our linear functions. So linear functions are straight lines. That's why they have the word linear in it, line R. So in a linear function, we have a degree of 1, so that means that my variable is to the power of 1, and it's in the form of ax plus b. In grade 10, what was the form? What did we say it was in grade 10? You remember the mx plus b form? What was m? Slope. So what's a going to be? Still going to be slope. Okay? The only reason we call it ax plus b is because when we're dealing with polynomial functions, we use a, b, So a quadratic function ends up being ax squared plus bx plus c. A cubic function becomes ax cubed plus bx squared plus cx plus d. It just keeps, they keep going using the letters as my coefficients. So linear function's a straight line. Another function that's a straight line is a constant function. So in a constant function, the power of x is 0. So f of x equals just a constant value, which means no matter what x is, the value of the function is always a. So how does that look when I graph it? So we'll look at number 2 first. Y equals 5 means no matter what x is, the value of y is always equal to 5. So if x is equal to 0, what is y equal to? If x is equal to 3, what is y equal to? If x is equal to negative 6, what is y equal to?
Probably 5.
So what kind of a line am I getting?
Straight line.
Okay, and how would you describe that straight line?
Horizontal.
A horizontal straight line. And that horizontal straight line is going through what point? 5. So what do we call this point? Right here. The value of it is 5, but what do I call it? The y-intercept. It crosses the y-axis at 5. Okay. What would be the domain of this function? So what are all my possible x values? So a better question to ask, what can't x be? Or can x be anything? X can be anything. So how can I express that?
X is such that x is any real number.
Yeah. So that would be using set notation. What if I wanted to use interval notation? And what kind of brackets would I use? Right. Okay. What's the range? What are my possible y values? Say it louder. 5. That's the only thing y can equal. So in set notation, set a y values such that y equals 5. In this case, I don't even have to say what number set 5 belongs to because it's just the single number. If I wanted to do this as interval notation, the number 5 with what kind of brackets? Square, because it includes that value of 5. Okay? Quadratics. So quadratic functions have a degree of 2. So they have an x squared. And we spent a lot of time looking at quadratics last year with the quadratic formula, that nice square or negative b plus and minus the square root, all of that fun stuff. We looked at the roots, we looked at the x-intercepts, we looked at the zeros of quadratics, we factored quadratics. We spent a lot of time with quadratics. So quadratics, we usually express quadratics in 2 different types of forms. We have general form. General form is like I was telling you before with that a, b, and c. So ax squared plus bx plus c. A, b, and c are real numbers. A can't equal 0. Because what happens if a equals 0? It's not a quadratic because this term would disappear. And what would I be left with?
Bx plus c.
And what's bx plus c going to give me?
A linear function.
A linear function. I'm going to get a straight line. And then I've got the standard form. Standard form has some interesting information on it. What do you remember about the p and the q? The vertex. So the vertex is that kind of, it can either be a minimum point or a maximum point, depending if the graph opens up and down. How do I know if the graph opens up or down? I look at A. And what specifically about A do I look at?
Whether it's positive or negative.
So if it's positive, it opens, and if it's negative, it opens down. So let's write that in. So P and Q is my vertex, and A tells me if it opens up or down. Down if it's negative, up if it's positive. Okay, so now use your graphing calculator to sketch the graph of this equation and determine the following information from it. So I'm going to give you a couple of minutes to go through that on your own. Remember how to use these fun calculators.
You wouldn't happen to have any batteries, would you?
Okay, so when we go through to put this in on our calculator, we go into the y equals menu, and we've got the x squared minus 3x minus 18. So it looks like that. This tries to focus. There we go. So then when I graph this, if we do a zoom 6, which is your 10 by 10 grid, that's what happens on the grid. You don't actually see the full graph. I want to be able to see the bottom half. I want to be able to see where that dip is. So I need to extend my y values. So that's pressing the window button and then change my y min to try negative 20. And then if I graph it again, I can barely see the tip of it, so I could change it again to be a negative 25. So again, if I change that window setting to make my y min, that's what it would look like on your page. And then if I graph it again, there's the graph that I want to be able to see. I want to see where it crosses the y-axis and where it crosses the x-axis. So then the zeros of the function, where do I find the zeros of the function? And how do I find the x-intercepts? So it's second trace, so second calc, and then I'm going to go to 0, and it's going to ask me for that left bound, right bound. So the left bound is the left side of the 0. So if I'm looking at this 0 right here, I need to be on this side of it, so I need to be on the left side and then the right side. But when I'm over onto this side, the left side's in the negative. So if I find the first one, the 0 that's on the negative axis, when I'm setting it up, if you look at the arrows that appear kind of below the equation, if the arrows are pointing at each other, that means that's a good thing. If they're not pointing towards each other, you're going to get an error. So then if I press enter, I get a 0 of what? Negative 3. And when I do the 0 on the other side, what do I get? 6. Positive 6. Okay. And where's the y-intercept?
Negative 18.
Okay. Where do you see negative 18 in the equation?
Constant.
It's the constant. Because what's the value of x? The value of x is 0. So if x equals 0, these two terms will disappear, leaving me with the negative 18. To find the coordinates of the vertex, how do I do that? So I have to go second calc again, and I find the min. Okay, and what do you get for minimum values?
1.5 and negative 20.25 or 3.
Okay, so 1.5 and negative 20.
3.
Is it exactly 20.3?
2.5.
Okay. What if I told you to express it as fractions? What would you do? How can I change these to fractions? The first one's 3 halves. What about the negative 20.25? I can do the math frac. That's fine. And I get 81 quarters. The other thing that I can do, I don't know what I'm doing. Okay, you type in -20.25
Oh, okay.
and then math frac. Okay. The other thing that you can do too is when I have my minimum, so I'm going to put my minimum up. So my calculator with the rounding or resolution gave me like 1.49 repeating and then -20.25. Okay? If I went back to my main screen, so I quit and I go back to my blank screen. If I went alpha 1, the letter Y pops up. Okay? So when the letter Y pops up, if you press enter, -20.25 comes in. And then I could go math frac from there. So -20.25, I can type that in manually myself because it's a terminating decimal. But if it was not a terminating decimal, if it was a repeating decimal, if it looked kind of funny, I could use that system to get it onto my screen so that I could math frac it. Okay? So then, now that I know the vertex and I know my y-intercept and all of those, I can use that to help find, to determine the domain and the range. So domain were my possible x values. So I have this vertex that's at 3/2 and -81 quarters. This y-intercept of -18, zeros at -3 and 6. So what's the domain?
-infinity to positive infinity.
Yeah. The domain can be anything. There's any possible x value that I can have. So domain, -infinity to positive infinity. What about my range?
-20.25 to infinity.
-20.25 to infinity. And what kind of brackets would I use? 1 square and 1 curved. So the brackets don't have to be the same. Okay? Now, when we're determining zeros, we can determine zeros by factoring. So we can take that quadratic equation, x squared minus 3x minus 18, and we can factor it. And there were multiple ways that we could factor that we looked at last year. First thing you always look for, can you remove a greatest common factor? Is there a term that I can remove from each, or a common factor that I can remove from each term? In this case, no, there isn't. When I'm dealing with quadratics, we have a couple of ways of factoring them. If my coefficient in front of x squared is 1, we do factoring by inspection. Two numbers that multiply to -18 and add to -3.
-6 and 3.
-6 and 3. So if I factor that expression, I get f of x equals x minus 6 times x plus 3. So if those are my factors, to figure out my zeros, let each of the factors equal 0 and solve. So if x minus 6 equals 0, x would equal 6. If x plus 3 equals 0, x would equal -3. And then the last thing that this question asks is rewrite the equation in standard form. So standard form is that vertex form. To do that, we have to complete the square. Yay, completing the square! Not really? Not even a little bit? Make this a bit bigger. There we go. So if we have to complete the square, the first thing that I want to make sure of is that the value or the coefficient in front of x squared is 1. If it's not, I want to factor that out of the first two terms. In this case, the coefficient is equal to 1. So I have my x squared minus 3x. Okay. This is the square that I want to complete. So to complete this, what I do is I take that negative 3, divide it in half, and square it. So if I take negative 3 halves and I square it, square the negative 3, and what do you get? Square the 2 and you get, so I get 9 quarters. So I'm going to add and subtract 9 quarters. Because what's the value of positive 9 quarters and negative 9 quarters? 0. So I haven't changed the value of the equation. I've just changed the way that it looks. And then I have my minus 18. In completing the square, these 3 terms now become a perfect square. And to factor a perfect square, I take the square root of the first, the square root of 9 quarters, which would be 3 halves, and then I use this sign in the middle, and it would be squared. Because if I FOIL this out or I expand this out, I would get x times x, which is my x squared. I get the negative 3 halves times the negative 3 halves, which would be my positive 9 quarters. And then I would get a negative 3 halves and a negative 3 halves, which would give me negative 6 halves, which would give me my negative 3. And then this part in here, I would clean this part up. So if I took negative 18 and I wrote it as quarters, how many quarters would I have? It's not 81, or no.
72.
72. And then together, this would give me 81. So there's my equation. X minus 3 halves squared minus 81 quarters. And from this standard form, I now have the vertex. The thing to remember with the vertex is my standard form is always written in the form of x minus p. So ignore the minus and look at just what the value of p is. The value of p is 3 halves, so this would be a positive 3 halves. If this would be x plus something, so if it would be x plus 7 squared, think of it as x minus negative 7. So then the p value of my vertex would be negative 7. Okay? Okay, let's use a graphing calculator to sketch the next quadratic. So if I go to graph this, before I even put it into the graphing calculator, I should know that this quadratic opened upside down. Why? Because a is negative. So it doesn't matter if it's in standard form or general form. If that coefficient on my x squared value is negative, the graph's going to open upside down. So what were the zeros of my graph? To the nearest hundredth.
Negative 0.22 and 1.5.
1.52?
5.
Sorry. And if I tried that trick that I told you with the last question, and I had pulled those values, in this case, when I got my 0 and I got that negative 0.22 and it went on, if I went back to my main screen and pressed X and then enter, that value would come up. And then when I tried to math fracket, nothing would happen because I can't make it a fraction. So if I can't write a number as a fraction, what kind of number is it? What type of numbers can't we write as fractions?
Irrational.
Irrational numbers. The definition of an irrational number is one that can't be written as a fraction. If I can't write it as a rational, it has to be irrational. So I can write irrational values as exact forms using the quadratic formula. So my quadratic formula is x equals negative b. So b is 4. So negative 4 plus or minus the square root of b squared minus 4ac. So the a, b, and c come from the general form of the quadratic equation. All over 2a. So we get negative 4 plus or minus the square root of 16, and then this is 12. So 16 plus 12 is 28 over negative 6. And then I need to look at that negative, or that 28. I need to check whether or not I can simplify that radical. So to simplify the radical, we look, can I divide the radical by a perfect square? So can I take 28 and divide it by a perfect square number? 4. 4 times what? 7. So then the square root of 4 is 2. So the square root of 28 becomes 2 root 7 over negative 6. That leaves me with 3 coefficients, the negative 4, the negative 2, and the negative 6. They all have a common factor of 2. It's actually a common factor of negative 2. So negative 4 divided by negative 2 is 2. And then 2 divided by 2 is 1. And the positive and the negative would still stay as positive and negative. And then over negative 3. And if I took my calculator and went bracket 2 plus the square root of 7, bracket divided by 3, I would get, sorry, that shouldn't be a negative 3, that should be a positive 3. I would actually get plus, I would get 1.55. If I went 2 minus root 7 divided by 3, I'd get negative 0.77. Okay? Okay, I'm going to stop there for today. Yay. So when I take this x minus 2 squared and I expand it out, what do I get?
X squared minus 4x plus 4.
Great. Remember, there's that middle term that I have to get in that when I expand it out. Typically, we remember the x squared and we remember the positive 4, and we forget the negative 4x. Because that x minus 2 squared is x minus 2 times x minus 2. And then I multiply the 4 by the x minus 2, add 5, and then I'm going to collect all my like terms. So I get x squared, the 4x and the negative 4x will cancel each other out, and then 4 minus 8 plus 5 equals 1. So I get x squared plus 1 as a result. Good. Okay, so let's look at class example number 8. It says, consider the function f of x equals x cubed. Match the function on the right with the expression on the left. So if I started off with x cubed, or sorry, if I start off with x cubed, and I go to x cubed plus 5, what did I do? What did I do to get this equation? I added 5. So if x cubed is equal to f of x, it means I take f of x and I add 5. That's 3. So I take f of x and I add 5. What did I do to go from x cubed to x plus 5 cubed? I changed the x to an x plus 5. So I changed the x to an x plus 5. That's number 1. So I changed the x to an x plus 5. How did I get 5 cubed from this equation? change the x to a 5. So I change the x to a 5. This would give me f of 5. And then d is the last one left. Has to match to 2, but I double check. How do I go from this expression to this expression? Replace x with a 5x. Replace x with a 5x. Okay? And then the last one, you guys don't have all 8 of these. I know which ones you have. So A, we have. So if f of x equals the absolute value of x, how can I write this expression in terms of that function? So wherever I see an absolute value, I can replace it with the f of x. So the absolute value of x becomes f of x minus 4. Okay. Nice. Okay? You don't have this question, but you have, this is your b, right? Absolute value of x plus 3 minus 2. So how do I go from this equation to this one? What did I do? So how do I go from here to here? I added 3. So I replaced the x with an x plus 3. And then the minus 2 is outside the absolute value, so I subtracted the equation by 2 afterwards. So I get f of x plus 3 minus 2. So then C and D. How do I get C? Multiply what by 2? F of x. I multiplied this absolute value by 2. So 2 times f of x. What did I do in D? So I replaced the x with a 2x. So now this would become an f of 2x. So yesterday I gave you questions 2 and 3 and 4. Okay? So today I want to give you, I just want to see if I want to give you question number 5 or not. Question number 5, A and C. And then question number 9, B, C, and E. 11, B, E, and F. And 12 to 14.